Hi, we are Team 34 and I'm Rishabh Modi. Our programming language is called CandyApple.
Hi, I'm Maitri Thakkar.
Hi, I'm Ayan Shah and we have created our language in Prolog, and for tokenizer we have used Java.
Our language has the following features. First is support for operators and primitive data types such as integer, float, and boolean. Our language also provides support for assignment statement to assign a value to an identifier. The language supports decision statements such as if-then construct and if-then else construct. It provides support for iterative execution by using a while-do construct. It also provides support for print functionality to display on standard output. This is the workflow of our language. The key components of our language are tokenizer, grammar, parse-tree, and interpreter. The tokenizer takes the source code as an input and creates tokens. These tokens will act as input to the parser. The tokens are formed as a list in Prolog where each token is separated by a comma. We tried to create our tokenizer in Prolog, but we were unable to get input for specific characters in Prolog, so after consulting the TA, we implemented our tokenizer in Java. In the tokenizer class, we take the input from a text file where the source code resides. The text file is interpreted character by character and tokens are generated simultaneously. Here is the logic for creating a token list. The buffer reader will read the input from the text file and each character will be checked against a regular expression to identify different words and special characters. After the token list is generated, the tokenizer will generate an output file called runprogram.pl, which can be directly executed to generate the output of our language. That is because the run program file will include the call to the parser and interpreter with the generated token list.
Now we'll look to the grammar. The grammar acts as the backbone of the language. It defines the syntax for the language and the functionalities that the language supports. Grammar is in the form of BNF. Next, we will see the parse tree. The parse tree will be generated from the DCG in Prolog. The parse tree will be in the form of abstract syntax tree and it acts as an input to the interpreter. We will look at the logic that is used for the parser. We have defined a block starting with begin and ending with end. Our statement list consists of declarative statement, condition statements, and output statements. The declaration statement declares a variable and defines its value. The variable can be of integer, float, or boolean type. Our condition statements consist of if, then, end if declarative statement, if, then, else, end if declarative statement. We have implemented while loop as an iterative construct. The output statement prints any expression that can be a variable or a number. We have implemented assignment not equal, less than, greater than, less than equal to, and greater than equal to operations. Next, we have also implemented arithmetic operations like addition, subtraction, multiplication, and division. Our variable names can range from A to Z and our numbers can range from 0 to 9.
And so now we move on to the interpreter. The interpreter will act as a runtime environment for the language. The interpreter will take the generated parse tree as an input from the DCG, and it will evaluate each symbol in the parse tree and call its appropriate evaluation function to generate the desired output. So here we have the source code for the interpreter. The interpreter will take the parse tree as an input from the DCG and evaluate each symbol from the parse tree. So initially it evaluates the symbol for parse tree, which leads to the evaluation of symbol block, which leads to the evaluation of the statement list, and so on. So thus for each symbol in the parse tree we have an evaluation function. Now, the statement list can consist of evaluation of declarations, conditions, and output list. That is print statement. Declarations can be of type integer, boolean, and float, where we can assign a value to those declarations, or we can just declare a variable. After the declaration statements, we have the condition statements. The condition statement evaluation function eval for symbols like condition equal, that is assignment condition, if then condition, then if then else condition, and while condition. These conditions evaluate the condition exactly like the DCG, where they evaluate the value of the expression, uh, unify the identifier to Z, and look up for Z in the environment and update the environment to a new environment. Then we have the output print statement. Currently, we are supporting just the print statement for printing out an expression, which can be a long expression or an identifier or a number. After that, here is the evaluation for if conditions. When the if conditions are called from the condition evaluation, they first check for if clause or the if else clause. The 1 and 0 here define the true value or false value. So if the condition is true, it will evaluate the statement list within the if block, and if the condition is false, it will evaluate the statement list within the else block. After that, we have the while loop. In the while loop, the in the evaluation of while loop, it will also take a condition. It will also take the parse tree symbol for the while loop itself as a parameter, so that when it evaluates the statement list within the while loop, it will again check for the evaluate while condition. So it will keep looping within that condition until the while loop has boolean expression is false. After that, we have evaluation of assignment values. Uh, that is, we have to evaluate integer, evaluate float, and evaluate the expression types. So expressions can be arithmetic addition, subtraction, or multiplication and division. Um, Addition and subtraction are on at the top because we have implemented operator precedence where multiplication and division will be evaluated first in an expression, and after that addition and subtraction will be evaluated. Um, Also, we have an evaluate identifier predicate which will evaluate the identifier value by looking up in the current environment. Then we have the Boolean expressions which can be equal to, less than, greater than, less than equal to, greater than equal to, and also negation. So when a Boolean expression is called in any of the conditions, it will correspondingly call the predicate to check if the value is less than or greater than or less than equal to or any of it, and accordingly set the uh, condition value to 1 or 0, which is true for 1, 0 for false. And then we have the lookup and update predicate to look up any identifier from the environment, and or to update any identifier in the environment. Thus, this concludes our source code for the language.
Now, let's look at some sample programs. The first one is a simple arithmetic program. This program displays the arithmetic operators and print functionality of our language CandyApple. We start our program by declaring a code block using the begin keyword. We can declare identifiers anywhere in the code as it is considered as a statement in our grammar, and statements can be declared anywhere. We assign values to integers x and z and perform different types of arithmetic operations on the identifiers. In this case, we perform addition and multiplication on the identifiers. In the end, we use print keyword to display the value of the desired identifier, which in this case is 10. We end our block by using the end keyword. Let's look at another program. This program shows the control statement functionality of our language CandyApple by using if and else statements. We start out our code by declaring the begin keyword just like in the previous program. We have two identifiers x and z. We manipulate x and z using logical operators and transfer control using if and else statements. In the end, we use the print keyword to print the desired identifier, which in this case is 5. We end the program by using the end keyword, just like the previous program.
Here we have the program to calculate the factorial of a number. Initially we declare integers x and z, and after that we run a while loop for condition x greater than equal to 1. In the while loop, it will keep multiplying the value of x to z, and when x is equal to 1, it will end the while loop and print the factorial of the number in the console.